Sorry, if that's okay. Is that all right with you?
Oh, it's fine with me. Yeah.
Okay, cool. Uh, I think we're recording. Go
Great.
ahead. Sorry.
Okay. And before I jump into external tables, Drew, I know we had that list of agenda items. I'm wondering if maybe like 14.1 would be a nicer way to like ease in to the meeting,
Sure.
because I feel like that external table discussion is just
Well,
yeah.
okay. Yeah, 014.1 is a predominantly like bug fix patch release. We can actually pull up the changelog and we can take a look. We released a whole lot of code in 014.0, and somewhere between miraculously and impressively, we didn't break too much in the big 014.0 release, which is great. There's a couple of really key updates that we're excited to roll out too. So I'll share my screen. We can check out the sort of in progress changes that have already been merged for 014.1. So primarily bug fixes, but there were a number of like smaller feature enhancements, like feature improvements too. I think Martin, who just joined, made one issue that we fixed here as well, which is exciting. So summarizing warnings at the end of DBT runs, this is gonna be really cool. We can check out a quick screenshot here. It's gonna look something like this. So before, if you had warnings in your tests, they would just like show up as being successful. In the status line at the bottom, this would have shown pass 3, but now it's just pass 1, warn 2, and we'll also get the actual warnings out as log level information in the summary. I think it'll be really helpful for people that have like maybe flaky tests where they want to know if things have failed, but not necessarily like wake everyone up at midnight if they do. That'll be good. This was a pull request submitted by, the GitHub handle. I have to think about who the person is. A member of the community, Ben Edwards. Perfect. So on Postgres, before we were running the query, check the catalog one way. Ben made a great pull request that will make it both faster and return more correct data for like custom types, for instance. And it's also like all S code. It's pretty exciting. A bunch of doc site updates. Happy to talk about those. Sort of like under the hood stuff. Speed improvements, debugging, development improvements. This is like a Snowflake internal field that we're setting now, which is nice. This is the big one for me for 014.1 that feels high priority. Oh, interesting. Sometimes you get slacks. I'll leave Slack open. Okay, sorry. So this is a big one. If you're using snapshots with the check call strategy, there's sort of a bug that can occur if you get into a weird state with your data. This one's the high priority one because snapshots are sort of not idempotent and totally rebuildable like the other resources DBT. The problem is sort of what's described. That's actually a different issue. The problem is like if you're checking columns for changes and you have, well, I guess first of all, is everyone familiar with snapshots? Or at least Josh, are you a little bit? Okay. The idea is we want to capture changes to a table when we don't have like, say, a reliable, really what you want is like a table full of changes. So like at this time, this value changed from this to this. Like that would be ideal. Sometimes you don't have that. In many cases, you will have an update at a timestamp. And so what you want to do is like record the change in that mutable table. So the state was this, and then the updated at timestamp changed. Now the state is this. You can kind of look back in time and see how the road changed over time. So it's like
it's sort of a cleaner, more like repeatable way to build. One thing you could do is build like type 2 dimensions.
Exactly. Yeah. Snapshots build type 2 slowly changing dimensions.
Yeah.
Ideally, this would be produced by like your source data system, but if that's out of your control or otherwise infeasible, you can use snapshots. In 014.0, we added a new type of strategy that isn't based on an updated at timestamp. Instead, it will look at a series of columns that you specify, your check calls. And if those change in the source table from the value that DBT previously recorded in the snapshot table, we can identify that a change occurred. We can insert an SCD type 2 record into our changelog instance. So there's a problem where just say you're checking the column name, and my name changes from, we'll say Drew to Andrew, and then back to Drew. If we have this cycle in values that we're checking, what can happen is that DBT snapshot will become confused and it won't record the actual change that occurred. So it's like a little bit specific, but given the nature of snapshots that they're like not fully rebuildable, it's important that we do exactly the right thing here. And I'm excited to get this one out because snapshots have only been, with like the check call strategy, have only been live for a couple weeks now. So if somebody is in this state, it will like limit the amount of damage that could be caused by this logic error on our end. So this one feels like high priority. I want to make sure that everyone that uses snapshots upgrades, and we want to make it really easy to upgrade. So like no breaking changes here in this release or anything like that. Any questions about snapshots or check calls or anything like that? Okay. This one's funny. Is incremental used to not actually check that the model was materialized as incremental? There's a good discussion here in which somebody, I am not exactly sure who, looks like it was Dave Howell, totally changed my mind on this. I felt like pretty sure that the existing implementation was like good and correct, and he made a really strong argument, and I was happy to fix the implementation of is incremental. So now if you use is incremental in like a table model or a view model, it's going to return false, which is like obviously the right behavior, which is good. What else? Just want to get the highlights here. Lots of other minor bug fixes, things that we've accumulated from like 0.14.0 and even backwards. A couple of these other ones are community contributed as well, which is great. That's the big highlight on 0.14.1. We've got a couple more changes that are in progress. We're going to cut our first alpha hopefully today, knowing that we have a couple other changes to merge in as well. And the goal is to release 0.14.1 for real early next week, maybe middle of next week.
Awesome.
Cool. Okay, regarding the very loose agenda that we have in place, what else? 0.14.1, great. I'm super interested in this like real-time data models in a batch-based process conversation. Although that is like a little bit out there, I am super happy to like discuss external tables. I want to learn more about how Josh, people like you are thinking about them, so that I can like incorporate that into my understanding of how this could work. And certainly like Martin, Nicholas, company, if you folks have anything you want to talk about, I'd love to address those things as well.
So I'm happy to talk about external tables for a bit,
Okay.
if we want to, and kind of how we're looking at it. And I know some folks you may have hardware issues or may not be in a space to do it, but just to echo Drew's thought, if you are able to turn on your video, it makes it a little easier when we're speaking. So, all right. So the basic idea of an external table. Oh, thank you. Appreciate it. So the basic idea of, it makes me feel less like I'm speaking to a robot.
Yeah.
The basic idea of an external table, and this has been around, I think Oracle probably first did it at least 10 years ago. Back in the day with Oracle, what it was, you were running Oracle on a server, either literally under someone's desk or in your data center. And you had some files, and for whatever reason, like maybe these were files that were only very infrequently accessed, or the data out of them was very frequently needed, but it would still be convenient to be able to essentially like not have to use Oracle like SQL loader to load the files into the database, to go through this painful loading process, only then to be able to query them. Maybe you weren't even sure if the data in them was good or clean, or if it would even be useful. So you just wanted the shortcut. And the idea was, man, I wish I could sort of query files from in the database, but have them look like tables. And so that's essentially what an external table was first back in the day. Like this is before Avro and Parquet and all these other fancy formats. It was like, I have a CSV, but I want in the database to have it look like a table. So it's sort of schema on read, like a long time ago, right? Before it really started becoming a thing in terms of Hadoop and S3 and all these other modalities. And there are some issues around it, right? Like, so when you create an external table, you say like, instead of create table, it's create external table. And hello, Emily. And you have to tell it like here, you have to tell it what the file format is. And you have to give it some information about data types and so on. But it's a little more complex than when you create a normal table, because when you create a normal table in a database, it doesn't have any data in it. You're just telling it, here are the data types. With an external table, you have to give this information about, like, here's what the delimiters are in the fields, or it gets more involved, right? And so that use case turned out to be a very good one. And, Redshift has Spectrum, which is external tables. And there are some implementation details that are a bit different about how these various platforms do it under the hood. But that's essentially the idea is, can I query a file or a set of files and make them look like a table? The nice use case for that when you're in the cloud is if you're building some sort of data lake, or you have an enterprise organization, or other scenarios where, like, so a lot of the folks that I see commenting about DBT are using it in smaller to medium-sized organizations, or they're using it in organizations where they kind of have control of the whole stack, all the way the data from the source, all the way it gets in the warehouse. But in a lot of places, you get multiple teams, and if you're the data warehousing folks and you're wanting to use DBT, and particularly if you have files coming in, if you're not using database replication from like a SQL Server and Oracle and landing it in Snowflake or Redshift or something, but you're getting files in, some other engineering team is just getting these files and probably dumping them somewhere in S3, and maybe it's your job to get them in somehow. And you can use that, you can do copy commands. But there's some pain and complexity around using copy commands and, having to keep track of what you already ran copy for and what hasn't been copied yet. And there are ways to work around it. But man, wouldn't it be nice if like I could literally have my sources in Snowflake, for example, be an external table that's pointing to S3, right? Mm-hmm. And so that's what I've been poking around with. And let me share my screen here. So I just was doing this morning. Here's our DAG, and there's a lot of jankiness in the underlying code here. So I'm still trying to figure out how to do this right. But the green items are so previously these tables that are prefixed with stage are our staging tables. And there's some macros and other stuff going on under the hood where we're either querying stages in Snowflake to load these directly, or we're using the copy command or something like that, right? But that's kind of invisible to the DAG, which is one of the reasons why I'd like to move away from that model, because I'd like to have more of that process be aware in the DAG, be more transparent to coders and DBT and everything. So what I did was I converted these two items that were previously staging tables to sources, and then I have macros that basically go and create the stages and then create the external tables for these. And I can give a little bit of a look at the code here.
Okay. This sounds very similar to something I think my colleague Jeremy worked on. I believe it was on Spectrum. But yeah, if you, to the extent you're able and willing to show the code, I would love to see what that looks like and maybe propose some ideas around how DBT could make this work better.
Yeah, absolutely. I still have some things embedded in there that I don't necessarily want recorded.
No, that's totally fine. So,
but here's what I'll do. Let me cut and paste out in a notepad file, and I'll delete, because I get it's a lot easier for you to kind of understand if you could at least see kind of.
Sure.
So, well, give me just a second here.
Okay.
Right. Can everybody see this this code here?
Yeah.
So this is kind of janky right now. I have a lot of hard-coded references to schemas and other stuff that need to figure out ways to parameterize out, right? But basically, this macro gets called as a pre-hook in my DBT project file, DBT project YAML file, and I deleted the URL reference, and we're using IAM roles, so I deleted the IAM role from here. So first I create the stage, and there's already a file format in Snowflake that got previously created in another macro. Mm-hmm. And then this is the actual part that's probably meaningful here for the external table creation. So it already knows where to go, like through the URL here in that I've deleted that refers to an S3 bucket. It knows where to go through.
So,
go ahead.
Okay, the broad question I have about external tables on Snowflake that I think there's part of it being shown here. It's like, how do you differentiate between which should be a stage and which should be an external table? Or is the thing that I'm looking at the fact that the external table points to a stage?
The external table points to a stage, but the thing is the stage doesn't give any notion of
schema.
Now here, let me, I can show you what it looks like if I actually query this external table.
Yeah, and oh, that's really interesting. You also were doing, it looks like you were computing expressions in the external table.
Well, you have to, because in Snowflake, you have to.
Okay.
If you want columns, because by default, what an external table does is it only gives you 2 columns back. It gives you a column called value, which represents each row as like a JSON array. And array or whatever.
Is it like $1 or is it different than that?
No, it's a little different.
Okay.
And then the $ syntax is when you're querying a stage.
Okay.
This is a little different. And then it gives you a column that's metadata $file name. So it tells you the name of the file that, because you can have hundreds of thousands of files like we do in some of your stages or whatever, right?
Okay.
So share this here. So I've created this external table. And by the way, you also, after you do this, you have to do what's called, you have to do this alter command in Snowflake to run a refresh. What that's actually going through and doing is telling Snowflake, go actually find all the files that are in S3 or Azure Blob Storage or whatever platform you're running Snowflake on, and like register them with the table. So it has to figure out, like at runtime when you query the external table, if you have auto refresh set to false, and without going down in the weeds right now, if you want this to work on Amazon, you have to do that.
Okay.
You have to go back and tell it to go like find the list of files. So then if you do that, so if I just query, like if I do select star here, and limit, take a second to come back. Now I have some other queries running right now, and I'm running into some other problems with this. So it may, oh, it came back. All right. So by default, like if I hadn't created all those other columns when I created the external table, if I didn't give it any column definitions, by default, I would only get 2 columns back. I would get this column, which has the row, each row.
Value.
And then I would get this column for the metadata file name over here. Tell me the file name.
Okay.
And then what all the expressions do is you give it the data type that you want, and you refer to the column name in here, and then you can compute out and cast and whatever to get the columns you want.
Okay. So this is a great primer. Thank you for showing this off, and also like nice work. Oh, it looks really good. Macros and hooks and things like that are convenient because they're very flexible. You can encode like whatever SQL logic you need. But I suspect there's a more native way for DBT to represent these things. The idea that we've had bouncing around over here is that sources in your source.yaml file, you have an opportunity to specify columns. And at that same time, you could probably also give data types and expressions, potentially, in a way that isn't tied specifically to Snowflake external tables or Redshift Spectrum external tables, things like that. But maybe there's a way that we could make like a materialization in DBT called, say, external table that is implemented appropriately for both Snowflake and Spectrum and whatever else. Like, this is a thing on Spark SQL, for instance. You have to create external tables. And so you can describe your source data set, enumerate all the columns. And I'm not exactly sure what mechanism this would use, but it's conceivable that DBT, when you do a run or DBT like source run or something like that, DBT could create these data sources for you as external tables, as opposed to just pointing to a table that was loaded by some other tool. You'd have to give an well, maybe a stage. You'd have to give a stage, and credentials or something like that.
But I guess file format, yeah.
File format, yeah. And maybe all that's just like configuration, and the materialization handles it in a per database way. Is that something that you've considered already, or something you think is like a good or maybe a bad idea? What's your initial reaction to that idea?
I'd love to make, it's definitely clunky right now the way I'm having to do this. And there are all sorts of issues that I'm running into. I'm running into issues about, like, there's no, depending if I do it an on-run start hook, that has one set of problems. If I do it as like a model hook with another model that's using it, there are another set of problems. There are issues I'm running into right now where tests that ran in seconds or minutes on data I had loaded into Snowflake are literally taking like an hour or more to run. And that's performance is a whole separate consideration. But I would definitely be in favor of finding a better way to do this than just having it be macros. And the approach you're suggesting sounds reasonable. Yeah.
Okay, cool. Let's.
Out of curiosity, why are you using external stages instead of loading in as a variant column?
So that's the approach we took previously, was loading in as a variant column, but then you have to end up using copy commands in order to do that. And then you have to keep it would be nice if instead of having to, so I already have all this data in S3 and it's staying there. And then I essentially have to keep a staging, like a raw copy of that in Snowflake in sync with what's in S3 and use that raw copy in Snowflake as a source for downstream things. It seems like kind of a waste or duplication to have to do that.
Okay. So that's the pattern I'm using, and I'm using Snowpipe then to ingest, so that just keeps it up to date as it lands. But then I have strong, offload to Glacier so that my cost goes down on the S3 side. And then my data lake is truly in Snowflake. But we're small, right? Like we're a couple terabytes at most.
You can absolutely do that with Snowpipe. One of the things that we were trying to avoid, though, with the way that we built this is with some of those other ingestion methods, if you have constantly incoming data, you end up running a Snowflake warehouse 24/7, essentially, to keep processing, or there are additional costs. And the way that we've structured it with external tables or with the previous way we were doing it, which is only pulling it in from the stages when we ran the dbt command, it meant that our warehouse would only fire up, run for the nightly batch, and shut down instead of having to keep this one warehouse essentially running 24/7 for data.
Gotcha. Yeah, and I have full control over it. So I use Kinesis streams to control like 10-minute drops, and then fires up, runs for a second, and shuts down. So it's pretty cost effective on my end, but I can see how that could spin out of control.
Is your name Alan?
Yes.
Alan, good to see you face to face. We do the same thing here at Fishtown Analytics. We have a Snowpipe set up that copies data from S3 into a proper Snowflake table. I do think that gets you pretty far. And that's kind of part of the question of like external tables is like, why would you use these things? I think, Josh, you make compelling points, but it's not one of those things where like, clearly people are using DBT and doing this work effectively without the external tables. It's like, there are specific reasons why you would want to do this and benefits that come with it. In this case, added complexity, but certainly a cool discussion. And I'm excited to figure out like at least what our options are. Though I'm not sure exactly how we will proceed on the DBT side of things.
I have a suggestion. I don't know if you guys have talked about it, but making like a serialized view over the top, but not in the sense that we're doing the materialized view in Snowflake specifically, because I did that and it just ran our costs through the roof. But let's see if I can share my monitor here. Okay. All right, I suck at Zoom. Where are we at? Share.
Really good green share button. Yeah.
Share screen there. So can you guys see my screen?
Yeah.
Boom.
Orange. How'd that happen?
Oh, yeah, you'll like this. So I just skinned it so it's branded.
I love that. There's a cool issue we're working on right now that is about configuring docs from inside your DBT project, and I imagine like logo. I don't know about like the font, but certainly custom CSS and stuff. Custom colors for notes is one of those things too. Okay, sorry, go ahead. That's great.
Yeah, and I mean, I can show you. I can just throw on the Slack whatever. I just threw it at my web guy, and I was like, "Hey, brand this for me."
Nice.
Kind of.
Okay.
And it's hosted statically on S3, so that's pretty fun too.
Sure.
But now that it's 14, I have to update that because I don't have like this link here. But yeah. Anyways, so like we go here and it's just straight up all that good jazz. Let's go see what the SQL is. So like here's that parsing of the JSON from a variant column, and then like here is, I mean, it's the exact same thing from the previous one, and then a union all with a select statement and a primary key, right? So just my next step is to macro this, but if there was a way to materialize it, and it would create both of these, like that would solve a lot of my problems.
Yeah, I'm very glad that you're showing this. This was like the topic that I was interested in discussing today. Did you know this ahead of time, or was this?
I know this? I just showed up today. I was like, oh, it's 11, and I can
right
on this.
The unique experience that I have as like open source maintainer is that I'll talk to 3 different people in the span of a week that all like want to talk about the same thing out of nowhere. And it makes me wonder if it's some crazy cosmic occurrence or if there is some blog post that everyone read that like started the gears turning. Cool. Okay, let's talk about this approach. I tease this in the office hour notes. It's like getting real-time data out of a batch-based process like DBT. And I think the approach that you described, if I'm understanding correctly, is a really good one. You have some presumably very big data set that spans back historically, where the historical results are mostly immutable. What you can do is transform and probably like condense the historical data set up to like today, and then have a view that sits on top of it, runs the same transformation for the new data, unions it with the old data. Is that the right idea?
That's exactly it.
Okay.
I'm like, especially when parsing JSON, it's a huge performance benefit to do the incremental table and then the view over the top. I mean, it cut queries down minutes.
Yeah, and you get fresher data intraday.
It's as live as it hits our S3 bucket.
Yeah.
So.
All right, so I played around with well, let me back up. The way that I first heard about this was like probably a year ago when I started playing around with it on Redshift specifically. I think Illuma has a concept called near real-time views. And I've never used Illuma before, and the docs are a little sparse, but it was my understanding at the time that it did something like this, where it would sort of stage historical changes unioned with a view for the intraday changes. And so I played around with a similar view that honestly, you mentioned materialized views, it feels very similar to me, but with maybe fewer constraints than like native Snowflake materialized views, and cross-platform in a way that you could do it on Redshift and other databases too, BigQuery for instance. So I made a materialization that does the cheapo version of this. I ran it on our internal Snowplow events table that has like a few 100 million events, and it cuts the time to query like a roll up that events table significantly just in my kind of quick and dirty testing. And it has the benefit of like, if we were pulling in Snowplow data real time via Snowpipe or something like that, we get real time data intraday. So I think it's really compelling. I think that there are some questions that I am interested in digging further into. Like, can you stack these things on top of each other? And like, how do optimizers perform if you have like a chain of 6 of these things? Can you build your whole data stack using exclusively this type of materialization? Like, at what point does it stop working?
I will let you know, because that's currently how I'm going to do it.
Plan. Okay, so maybe what I can do, I wonder if I have the code sitting around somewhere nice. Have you ever checked out a DBT materialization, Alan?
checked out a what?
A DBT materialization.
No.
Okay, let's take a look at one.
Drew, I think in your response to your point about how well do query optimizers deal with many stacked views in general, I mean, I've stacked views 5 or 10 deep in some cases, and it's highly kind of platform dependent. But I've seen it work reasonably well before, but it depends a lot on the platform.
Yeah, my instinct is that BigQuery and Snowflake will handle this kind of thing with no problem. I think that in my experience, Redshift's optimizer sometimes does the wrong thing with unions in views specifically. Like there's just a number of weird assertion errors and like confusion around types that we've seen. And so like, if we're going to provide this really powerful thing, we need to kind of give, the guidelines, like guardrails almost. Here's how you can use something like this. So it's all part of the exploration. Like, when does this work well? When does this fall apart? So, okay, what we're looking at here is it's called a materialization in DBT. This is pretty much a macro, but you substitute the word macro for materialization, and it doesn't take any arguments. You can specify here a specific adapter. So you can say like adapter equals Redshift or adapter equals Snowflake. And that will be the implementation of the materialization for that database. So for instance, if we wanted to look, we could see that the view materialization is, I think, shared by most of the databases that DBT works with, whereas incremental materialization is a little bit more custom. We have a different implementation for BigQuery and Snowflake and Redshift and so on. So this is like not a special thing. You could drop this directly into your DBT project and say materialized equals NRT view. In fact, I was going to change this to MView, just insofar as NRT is nearly real time. We'll call that MView. That might be a little more globally recognizable. So this is my first cut of this. I'm sure there's a lot that can be done differently here, but you can kind of ignore these things. They're just creating like relation objects that we're going to operate on. The real logic is here, right? So I kind of imagine that you have to give some sort of like a partition time. This is going to be like a date. So here in my quick and dirty version, our stage SQL is going to be select everything from your model code, whatever you supplied, where the partition is less than the current date. So what we'll then do is call the create table as macro for our stage table with our stage SQL. This will just create a table with like, I know this is a lot to follow. It's not like the best possible version of this thing. But basically the model name __ staged is going to be like the historical data. We'll just create that table. False here means it's a permanent table. And then on top of that, we have two mains. That's a bug. On top of that, we create a view, and we use our view SQL, which is select star from your model code, union all, select star from the stage table. This is a logic error as well, but this is the right idea. What we really want, yeah, this isn't right. What we really want to do, this is like low stakes live coding because we're not actually going to run the code. It's like select star from our SQL. SQL here is the model select statement. So select star from that thing where the partition column is greater than or equal to the current date. And then union that with our stage table. Let me get rid of this. Oops. And in fact, I think you might need SBQ here, but that's just like the Postgres. Okay, great. So something approximately like this is going to make it so that you can just write a model with a single select statement. And assuming that you have appropriate like performance tuning configuration in place on Snowflake, that might take the shape of clustering for really big tables. On Redshift, it's sort keys, Postgres indexes, so on. Assuming that you're like doing the right thing on this partition column, whatever it is, presumably timestamp, it should be super fast to just filter for data from the past like up to 24 hours. And probably the database won't have a problem computing this union. And
so what I did on my where clause is I did select max from my unique identifier of my source table and then greater than that.
When you say unique identifier, like
it's an auto increment as I load things. So they're JSON variant type in my case.
Okay.
So yeah.
So yeah, we could call this partition. Yeah, this certainly doesn't need to be a timestamp. If this was an idea, it would work. Except what we don't want is this current date here. It would be like, sure, select max of partition from this.
I think one of the challenges with this, with the auto-incrementing integer, that makes sense. If you're using dates, one of the challenges, well, even with the integer might be a challenge, is making sure you don't ever have an overlap or duplicated data between the existing historical table and what you're trying to union it with. And kind of what, if that failure mode does happen, does this do anything to catch it? Or is that like totally up to the user to make sure? Because I feel like that's kind of the biggest complexity around all of this is building the process to make sure that that's right.
Yeah, that's a really good question. Yeah, conceivably you could, I guess you would need like a reliable, like a loading timestamp.
Like a bucketing process. You have to make sure that the buckets are mutually exclusive and it's one or the other.
Yeah.
Right.
If you do have some sort of primary key, and this is a thing that would be concerning to you, because imagine in some cases it's probably not a big deal. Like if it's a clickstream data and you're going to run this thing intraday and it doesn't matter if there's like 2 duplicated events, out of a million, maybe you just, ignore that and reap the benefits. But yeah, if you do have a primary key, I guess we could amend this to say like where this is true and the ID is not in the stage table or something like that. Then you can capture it when this thing next runs, at midnight tomorrow. It'll get incorporated into the stage data set. Does that make sense?
Yeah, it does. And just, at the end of the day, it's all about the performance, right? And
yeah.
So if you're doing a where not in, and it's a big, either the tables are pretty large, and then we start to lose the performance benefits of this.
You're right.
And in general, I like this idea and I get where you're going. I'm just trying to think through all the things that could be a problem.
Totally. Yeah. Okay. So that's, it's really a good point. The easy version of this that we're showing here, when we call like create table as on say Snowflake or BigQuery, this really runs create or replace table with your SQL select statement. And so we're going to end up doing like a full refresh, but sort of by definition, if you're using this kind of like materialized view paradigm, you have incrementally loadable data. And so there's sort of a question of like, should this part be incremental? Like at the end of the day, should we just take whatever is in the like view SQL part of the query, this, and like insert it into the stage SQL, and then update the definition, in some sort of atomic, intelligent way? Go ahead. If you're gonna.
So I created my view. So ideally, we create the stage table, and then I create my view selecting max from the stage table, and go forward to eliminate that duplicate data potential, I guess. But yeah, for my case, it has to be incremental into that stage table. Otherwise, I'm running for an hour or two to.
Forever.
If I could make a suggestion about how we name this, I get why we kind of want to call it an MView, but I feel like every single day somebody's getting confused. Oh, do you mean a DBT materialized view, or do you mean a Snowflake materialized view?
Yeah.
Which is sort of subtly a different thing. I liked the NRT view where.
Okay.
Yeah, I just having to talk about that like every day for weeks.
Just call it a Bannon view.
Abandoned view. I wish I came up with this. So, Alan, it sounds like you had the idea first, to be honest. Okay, how do we incrementally build the staging table? That's a great question. I'm going to take these notes and like pop them into an issue to explore this further. Then maybe we can like send out on Slack if anyone has thoughts. Be a great discussion. Okay, the what do we call this thing? Probably not materialized. This is interesting too, insofar as really what we're doing is building a hacky user space version of a proper materialized view that many databases support. I haven't played around with these on really any database ever, a proper materialized view. Like I know Postgres has them, you can call refresh on them, for instance, things like that. But I understand that of the warehouses that DBT works with, Snowflake introduced materialized views somewhat recently, and they have like pretty severe limitations for the types of SQL that you can actually write in them, right?
Yes. No, I mean, the biggest one is no window functions.
Okay.
There are a whole bunch of others too. Yeah.
Yeah. So really, we're not going to constrain you on the types of queries that you can write, but we are going to constrain you on the types of models that you can reasonably build. Like if you need to create a model that does a window over the past 7 days or something like that. Oh, I have to think about the exact scenario. But if you need like, would that work?
I wouldn't, I think maybe part of this is conceptual. Like when Oracle is again the granddaddy on this, and their notion of materialized views is everything that you would really think in an ideal world, which is essentially any SQL you want, I think. And you have two options with it. The underlying database, like you can literally have the materialized view update in real time, but that can incur a huge performance penalty depending on what's going on in the underlying tables that the materialized view is referring to. Or you can tell the materialized view that it can become stale, and you run manual periodic refreshes. I feel like what we're doing here is not, it's really almost more what I would call like a bucket view or something like that. It's like we're trying to have two buckets of data, and just for the purposes of keeping up to date. And then it's a more narrow use case than a materialized view, because an MView really the ideal version doesn't have any dependency on this idea of like having to have timestamps in the source or having to have mutually exclusive underlying data sets or any of that. This is a narrower use case, I think.
Yeah. I think that's totally fair. I think even like near real-time view isn't totally appropriate, because it is like real-time, and it's not really a view. So yeah, we'll have to figure out a name. The thing this reminds me of is BigQuery intraday tables. If you do either you have any experience with BigQuery? If you use like streaming, oh, hold on, we're getting a quick note from an attendee here. Martin just wrote in. If he remembers correctly, Illumina was using something like row number over great to Martin, do you mind pasting this right in the Zoom chat if it's not too much trouble? It sounds like Illumina used this to do deduplication on source data, because it's more of a data loader than like a data transformer. That's interesting. Cool. Thanks for that, Martin. The thing I wanted to point out here, I don't know exactly where it's going to be in the docs, is BigQuery does something similar with streaming data, where GA real-time sessions.
So what drove me to this is I went to the Snowflake conference, and they launched materialized views, and I was like, yeah, that's awesome. I went back and I actually implemented it in the hotel room.
Okay.
And then the Monday I got back, it had run for about a week, and I had accrued like 300 credits billed.
Right.
Where my Snowpipe was at like 100. So it, 3x what I'm ingesting in a week.
We've seen similar things too. Yeah.
What was the performance like? Were the materialized views snappy to query, like as though they were permanent tables, or did it feel noticeably somewhere between a view and a table?
Between what I've implemented in DBT and what I did, I didn't get to play with it much. I just had it running. My analyst loved it. But it's, if I run DBT twice a day, it's almost unrecognizable on my end.
Okay.
Drew, on that one, it depends. Like in Snowflake, basically they have a background process that's constant. It's a separate warehouse, and a visible one that you get charged when it's running to update the MView. And basically, if the MView is stale because they haven't finished updating at the point you query, it defaults to running as a regular view with all the performance penalties. If it's not stale, it looks like a table, but you would never see anything in between.
Yeah. Okay.
And then you can cluster off of it in Snowflake, but I mean, you can accomplish that with sorting.
Yeah. Just throw an order by on there. Yeah, I mean I think that's going to be a key component of this thing is like assuming that the optimizer in Snowflake and hopefully Redshift is really good. If we do order by or add a sort key for Redshift in the stage table, maybe it can figure out exactly where it needs to look for a given data point in this view that unions the two data sets together. I like have a lot of confidence that Snowflake will do the right thing, and that seemed to be the case in my testing. TBD on Redshift.
So my materialized view that I'm currently running, the biggest one I have is 300 gigs of data, and that's like 14 billion rows.
Okay.
And I mean, it's pretty responsive, even with the extra small compute warehouse when querying against it. So.
Okay. That's fascinating. Thank you so much for sharing that. I think it's really pretty wild that you came on to talk about that too. That was the big topic on my mind for today. Okay, here's the thing I think we need to figure out architecturally. dbt has a notion of materializations. There's existing incremental logic locked up in dbt's incremental materialization. And to do this NRT view, bucketed view type materialization, we really want to like borrow a lot of that logic from incremental models. And I'm curious if there are good mechanisms in place to, when we build the staging table, be able to like build this thing incrementally without kind of invoking the whole materialization. You know, I want to split these things apart a little bit more if possible, such that we can have these kind of higher order materializations that are composed of like sub-materializations. Like for instance, there's a cool materialization in dbt utils called insert by period or something like that. This helps you incrementally build a really big table, but not with a single big insert statement. It'll run a series of them once per day or once per month or something like that. And I think it'd be cool if we could figure out a way to build something similar that maybe built like permanent tables and union them together, for instance. That would also be pretty interesting. Then you could replace individual partitions. So higher order materializations that create multiple views and tables, I think are really interesting and like top of mind for me these days. Trying to figure out how we can better expose the components in dbt so that they can be consumed by other parts of dbt. If that makes any sense at all, that might be like a little bit out there. Oh, I think you might still be muted.
I'm good at that. So I'm actually about to make another materialized view off of this just for like the last 30 days of data, because obviously we don't want to query against the 300 gigs all the time.
Sure.
But yeah, if we physically partition tables incrementally, then that would make that very, very easy.
Yeah. These questions are really interesting. They sort of break the original paradigm that dbt operated under. It was like you have one model, it creates one table or one view, and that's not a sacred constraint. There's no reason why it needs to be like that. But as we like consider things like this.
Well, could you do an incremental table like we normally do, and then materialize view extension, reference the initial table, and then that is how it'd be one-to-one, right? And pass in whatever parameter of unique identifier.
Yeah, so like, let me pull up an actual materialization. We can look at it really quick. The problem is mostly around the, like, not the core materialization logic, but more the things around the edges. So if I share my screen and we look at, is this the right one? Can you see GitHub?
Yep.
Okay. I don't know how widely known this is, but inside of dbt, there is a dbt project called the Global Project. It's named dbt. It's like a regular dbt project. And there's a macros directory. And inside of here, there are materializations. We can look at the incremental materialization. So this is all dbt core code, but you could take any of this code, put it in your project in the macros directory, and dbt would pick that up just as well, which is pretty cool. This is actually not the right place to look because we are, it seems like we're all Snowflake people here, DBT. Oops, that's not right either. Okay, plugins, Snowflake, DBT, include. A lot of clicking on this one.
I won't remember this.
Well, I can send out links here, whatever. This is all public, like feel, definitely peruse this, check it out, let me know if you have questions. So there's a lot of logic here. This is the incremental materialization, and you can see it's the Snowflake specific implementation. So the exact logic we're going to run for Snowflake is different than Redshift because Snowflake supports merge, Redshift does not, whatever, things like that. And I think the problem that we're going to run into is that there's no specific part of this that we can pull out that actually does this is kind of the build a table incrementally logic. We say if you're in full refresh mode or the table doesn't exist, just run a create table as. Otherwise, create a temp table for your model SQL, do this column expansion thing, which I'm happy to talk about, introspect the table to get the column names, and then basically merge in or otherwise delete and insert. So just basically merge in the changes from the staging table into the destination table. So this here is really the core incremental logic that I want to reuse across different materializations, but it's tied up in how we run hooks, outside of transaction, inside of transaction. And when we have these one model produces multiple resources questions, it's how should hooks work? Do we run grants for each of the things that are produced? Do we only grant on the actual resource that's exposed to end users? So in this case, the view, but not actually grant on the stage table. We have to answer those questions. I feel very good about our ability to do that. It's just I think not obvious exactly how some of these things should work. Same here. It's if you're trying to build an incremental model, but the thing already exists in the database as a view, we have to drop it first. So it's we probably need to get more clever about how that works if you're creating multiple things. Does it already exist? It's incremental. What if it exists, but it's a view and it's a subtable? It's just a lot more logic we need to encode it and maybe separate a little bit better in the DBT code base.
Let me ask this. Say Snowflake, and I realize part of this is the cross-platform complexity, but say Snowflake improved materialized views significantly in 6 months, and we didn't have some of the SQL limitations that we do now. Would we really do this then on Snowflake, or would we just use one of their M views?
Yeah, I think you would just use the Snowflake materialized view, for sure. I mean, ultimately, here's how I think about all of this. In an ideal world, every DBT model that you make would just be a straight view. It would strictly transform data. You wouldn't run DBT periodically. Maybe you run it once you've merged a pull request and your logic changes. DBT should strictly manage the logic, of your transformations. In practice, performance does not permit you to do that. And so we have to create tables, and it's slow to create tables, so they're incremental and well, they're out of date, so let's try this nearly real-time view. These are all, in my mind, stopgaps, where the best possible version of this thing is just DBT creates views across the board, and we leave it to the database to execute them immediately. But sort of major developments in how computers work, that's not going to happen anytime soon. So I'm happy to stopgap on the Snowflake case, and for other databases that don't support materialized views. I think this would be a great and compelling thing to implement there as well. And we're close on time. I have a little bit extra if anyone wants to stick around and keep talking about this stuff. But this comes up with tasks on Snowflake as well, wherein I think there's a world where you can create tasks, and DBT is maybe going to be responsible for creating those tasks and managing them when your logic changes, but not actually running on a schedule to refresh them. And I think that's really compelling. The fact that you have to run DBT hourly or every 30 minutes to keep your tables up to date is, I think, unfortunate in a lot of ways. Where possible, I'm happy to leverage the database and native functionality of the database, because I think it results in better experiences for the database users.
So if I heard that right, I mean, Snowflake just launched those streams and tasks, and I mean, just pre-hook or run it just to set up as the model builds or runs the first time. But you're talking about implementing that for databases that maybe don't have that? Is that?
Oh, I don't think like there's a world where dbt implements streams or tasks on things other than Snowflake, but I am happy for it to utilize streams and tasks on Snowflake. Even though that would like take away, I shouldn't say take away, it would obviate the need for like some parts of dbt. Like you're not going to be running these things on a schedule so much. It's going to be less about deployment because deployment is just like telling Snowflake, here's my logic, as opposed to like rebuild this table at the data set thing. And I'm happy for that to happen. I was more saying for if we build these like bucketed views, near real-time views, things like this, there's no analogous concept on databases like Redshift or BigQuery. And so I'm happy for this to exist there, even if Snowflake has a native answer that might be superior, like materialized views. That in 6 months from now when they aren't so limited. I think the database is always going to be best positioned to know like when source data has changed and propagate those changes to downstream objects in the database. And so I want to let the database do that. Like it's always going to do a more immediate and correct and better job than dbt is. And then where dbt helps is like your logic changes and you have to redeploy these things. And it, in some ways feels more like Terraform than like Airflow. If that's an analogy that resonates.
Yep.
Yeah. I intentionally avoid like the streams and tasks just because the documentation in dbt is that value add that's so critical to anyone who's not like me trying to explain how that works to my BI department versus check out this, DAG and you can trace it all the way back. It's
sure.
Pretty awesome.
Yeah.
I think another interesting long-term thing would be with now that we have streams in Snowflake, we look at the platforms that dbt currently like officially supports: Snowflake, Postgres, Redshift, BigQuery. I don't know about BigQuery. I know Redshift doesn't have a notion of a stream, which is like this more generalized, like CDC-ish kind of a thing, right? But now Snowflake has it. Postgres has something similar. It makes me wonder if there's space for this other conceptual kind of thing, which is like we start to abstract away in dbt the idea, maybe some of the underlying details of a streamy kind of entity, which in Snowflake is a stream, and in Postgres it's whatever their CDC table. And I know that some folks have been working on MS SQL, like community adapters, like MS SQL Server has a CDC table as well, right? So it's sort of interesting that this new object is coming out in more places.
Yeah. It is hard for me to know if, it's really hard for anyone to know, like, is this the way of the future or is this like a weird niche trend, I'm excited to like play around with this stuff and keep an eye on developments too. And certainly I hope that if you folks like see examples of cool things or implement cool things yourself, you'll send them our way.
Well,
it also
thank you very much.
Like, oh, sorry, go ahead.
I just want to say thank you very much. Apologies, I have to drop, but
cool,
appreciate it as always.
Thanks for joining. Really insightful stuff today. I really appreciate it.
Okay.
Josh. All right, Alan. Pleasure talking to you. Is there anything else I can help with, or questions you have, or anything?
No. Thanks for having me on. I didn't realize I was going to be participating this much.
Yeah. You. I'm surprised, shocked that anyone else is thinking about this stuff. I thought it was just me. It's actually like super relieving that I'm not a crazy person with these like harebrained like, oh, if we create a table and a view.
Oh, so one of the issues I had